go to a plus students.com. You need to go to the a plus students.com. You need to select math as your subject. Okay. You're in grade 9, so we would be doing a grade 9 lesson. The topic for today is number sequence. Number sequence. Number sequences. And the chapter number is chapter number 7. Okay. And the chapter number is chapter number 7. And the lesson number for today is lesson number 6. Lesson number 6. The name of the lesson is number sequence mixed reviews. Okay. So let's go to chapter 7 and lesson number 6. Okay. Welcome everyone. Grade 9s. Chapter number 7, number sequence, and lesson number 6. Okay. So the lesson says we are just reviewing everything. Okay. The first question we have, it says, find the missing number in the sequence. So the question number 1 states that, okay, find the missing number in the sequence. Okay. So the first number was 0. We need to find the pattern. Okay. So normally this is 1, 3, 6, and so on, right? But what we need to see is the first two terms, the term number. Okay, what we do is we write the term numbers over here. Okay, we say this is term number 1, this is term number 2, term number 3, term number 4, term number 5, and we need to find term number 6, right? So what we need to see is in between term number 1 and term number 2, it's not changing, it's staying the same, right? But from term number 2 to term number 3, it's changing. See, we cannot see a change over here between these two terms. But between the term number 2 and term number 3, we see a change. That plus 1 is there. How about the next term 3 to term 4? Can we say we see a change? 3 minus 1 is plus 2, right? And similarly, 6 minus 3 would be, or 3 plus 3 is 6. So what we can say is we see a pattern now that 0 plus, we added a 0 on the first term to get the second term. Then we added 1 to get the third term. Into the third term, we are adding 1. We are always increasing the addition by plus 1, right? So what should be over here? 6 plus what? 6 plus 4. That means the term number 6 should be 6 plus 4, that is equals to 10. Agreed? So what we do is we find the pattern. Okay, the answer is 10. The term number 6 in this sequence is 10 because we try to find out the pattern of the sequence. So what we did was, let's verify, is it still the same? 10 plus 5 should be 15. 15 plus 6 should be 21. Yes, the pattern is there. Okay. So welcome to the class. Let's continue with the question with the sequences. Okay. The next question what we have is, what is the missing number in this pattern? I'll just copy the question. For question number 2, it says, what is the missing number in this given pattern? Okay. We just did question number 1. We're looking at question number 2. So what we need to see is we do not have, if I would say, let's write down the term numbers on it first, right? We would say this is term number one, term number two, term number three, term four, and we need to find the term number five. Okay, agreed? So can I say that if these terms are given to us, can we say that, let's look at addition. This is plus 3, this is plus 5, right? This is plus 7, then this should be plus 9, right? Do we agree on this? So 16, that means term 5 would be equals to 16 plus 9, and therefore the term 5 comes out to be 25. This answer should be 25. But let's see if there is another way to do this. If we have another way to solve this question, okay? This was the first way. Can we say that if term 1 was there, can I say 1 squared would be 1? Can I say 2 squared would be 4? Can I say 3 squared was 9? Can I say 4 exponential 2 would be 16? But since this is term number 5, then this should be 5 exponential 2. That should be equals to 25, right? So there are multiple ways to solve any given sequence, right? This sequence is a geometric sequence, right? So we can solve this sequence by a geometric. This would be a geometric sequence because there is a ratio between the numbers, right? They're being squared. Or we can simply remove this geometric over here. We can say that sequences can have multiple ways to be simplified, right? We'll further do the geometric, okay, in the next examples. Moving on further, is this clear or any questions are there? Do you have any questions? So if there are any questions, please write them down so that we focus on them first, right? Before moving on to the next question. Thank you. Let's look at the next sequence. Okay. So question number 3 in the sequence would say type the missing number in the sequence, right? We know that term 1 first number is given to us, term number 2 is given, term number 3. We need to find term number 4, term number 5 is there, and term number 6. So what we can see over here is not an addition because there is a jump over here. 1 plus 1 would be 2, but 2 plus 2 would be 4, right? Or we can say 4 multiplied by 2 would be 8 multiplied by 2. That means every next number is being multiplied by 2, right? The next number is a twice of the previous number, right? So what we can say is this was times 2, this was times 2, then this should be times 2 as well, because this would come out to be term 4 would be 2 times term 3. That means term 4 comes out to be 8. Let's complete. Yes, 8 multiplied by 2 is 16 and 16 multiplied by 2 is 32. Agreed? Or we can say that, okay, term 3. Okay, there is another formula that is Tn. The term 1 is always the first term. A r to the power n minus 1, where r is known as the ratio. Ratio means term 3 is divided by term 2. It should have a common ratio. So can I say the ratio comes out to be term 3 plus 4 divided by 2? It comes out to be 2. The ratio is 2. Which term do we need to find? We need to find term number 4. So we replace n by 4. A is always the first term. Ratio we found over here. And 4 minus 1 would be 3. So can we say that 1 multiplied by 2 cubed and 1 multiplied by 8 would be equals to 8. This sequence is known as geometric sequence. Okay. So this question itself can be done in two different ways. We can simply do the, what can we do? We can simply do the multiplication with 2, or we can apply the geometric in it. So a sequence, a given single sequence can have multiple ways in which it can be solved, right? But the first one was way easier for us. We know that each term is a multiplication by twice, or it's twice of its previous term, right? That's quite easy for us. General. Okay. Moving on further, let's see what do we have here. Okay. It says find the next number in the sequence. Let's see question number 4. They're asking us to find the next number in the sequence, okay? Let's see how we can do this. The term 1, the first term is always term number 1, right? It's 4. The term 1 was 4, 6, 8, 10, and so on, right? Let's see what we can deduce over here. This is term number 1, term number 2, term 3, term number 4, term number 5 of the sequence, term number 6, term number 7, and we need to find the term number 8. Okay, the last term for the sequence, given sequence. So if, can 4 be multiplied by any number to make it 6? Or can any number be added to 4 to make it 6? If we say an addition is being taking place, right? So can we say that 4 plus a number would be 6, right? 2. But what is the difference between 6 and 10? That means 6 would not be 4. Would not be 6 plus 2 would be 8, right? If the 2 is constant, but the additive number is changing. So now we say 10 minus 6 would be 4. That means 6 plus 4 would be 10. Similarly, 16 minus 10 is 6. That means 10 plus 6 would be 16. So we can see a pattern over here. 2, 4, 6. This should be 8. 16 plus 8 is 24. 24 plus 10, yes, we still have a pattern. The number that has been added is increased by 2 with every term. This would be 12. Then this number should be plus 14. That means term number 8 should be term number 7 plus 14. That means term number 8, term number 7 was 46 plus 14. And the final answer, term number 8, would come out to be 46 plus 4 is 50. 50 plus 10 is 60. That means our answer comes out to be 60. Agreed? So we need to find the pattern how the sequence is changing, right? They can change by the same number that is added to the next term, or there can be a pattern of numbers that are changing when it's moving on to the next term. Okay, great. Are there any questions for this? Any confusion? If there is any confusion, any question, let me know. We'll move on to the question, okay? We'll discuss your confusions first. If there are any, then we move on to the next question, okay? So let's see what we can say about this question over here. Okay. The question says, question number 5 says, type the missing number in the sequence, okay? So what we can see is the first term, the first number in the sequence is the largest number. This is term number 1. We need to find term number 2. This is term number 3, term number 4, term number 5, and this was the last term for given sequence. 80, because it's reducing, that means it should be subtraction, right? After 80, we do not know the second term. So let's skip the second term. Let's go to the third term and the fourth term. Let's look at their differences over here. What is, if the difference between these two terms is the same, then we don't have any problem. We do the same over here. 70 minus 60. What's the difference between? We do a subtraction of 8, right? 62 to 54. How much do we subtract? We still do a subtraction of 8. 54 to 46, we do a subtraction of 8, right? minus 8. That means if we go from this point to this point, we do a minus 8. So what is term number 2? That would be term number 1 minus 8. Term number 2 would be 86 minus 8. That comes out to be 70 something. What is 86 minus 8? 86 minus 6 is 80, minus 2 is 78. That means term number 2 for us is 78, because we can still see the pattern. 78 minus 8 is 70. So each of the term is being reduced by an 8, right? In the previous examples, we were increasing the numbers. In this case, we are decreasing the numbers. So depending on the question, we would follow the rule, okay? We just need to identify the rule that has been applied over here, okay? So let's look at the next one. It's still, the next one is still decreasing, right? So whenever it's decreasing, we need to understand that it would be a negative number, right? A reduction in the number. Question number 6. Type the missing numbers in this given sequence. If I'll just copy the sequence over here, make them largely right. So can we say we have term number 1, term number 2 we need to find, term number 3 we know, term number 4 we know, and term number 5 we know, right? So if we need to find the second term, we cannot find a pattern between term 1 and term 2 because 2 is missing. We cannot find a pattern between term 2 and term 3 because term 2 is missing. But term 3, term 4, and term 5 would have a pattern, right? So let's follow the pattern and let's see what can be done. So what is, if we need to do subtraction? Because the numbers are decreasing, they cannot increase, right? From term 1 to term 5, the numbers have decreased. So that means there is a subtraction in the question, okay? So if we see 56 minus 53, sorry, 56 minus something would be equal to 53, right? That should be a negative 3. Agreed? We are subtracting a 3, right? Similarly, 53 minus something would be equal to 50. That would still be minus 3, right? That means 62 should subtract the same number because these two numbers were same. 62 minus 3 is 50 something. What would it be? 59. Yes. So we can say term 2 is term 1 minus 3. Term 2 is 62 minus 3. Term 2 comes out to be 59. Agreed? So this was a decreasing sequence, okay? I hope there is no confusion, no misunderstanding, any problems. If there is any problem, do let me know. We'll discuss that first. Okay, good. Thank you. Let's look at the next question. Okay, 1 minute. This was question number 6. We do question number 7 now. And question, let me just copy the question. Type the missing numbers in the sequence. Okay, we have a sequence over here. Okay. This is question number 7. Okay. And the question says, type the missing numbers in the given sequence. So if this sequence is given to us, see, we can see a big jump over here. That was 1, 4, 16, 64, missing number, and 1024 is jumping, right? It's a huge jump between the numbers. So it cannot be addition and subtraction. So we use multiplication. We consider multiplication because 1 plus 3 would be 4. 4 plus 9 would be 16. But we do not find the same sequence. If we are adding the numbers, the first one is 3, 9, and so on, right? But what we can look at is multiplication. If this was term number 1, term number 2, term number 3, term number 4, term number 5 we need to find out, and term number 6, right? So we can find a relation between the first 4 terms easily. Term 1 is given, term 2 is given, 3 and 4 is given to us, right? We can find a relation between these. So can I say that if we need to, one needs to be multiplied by 4. If we multiply by 4, we get the 4 as the answer, right? But again, if we multiply 4 by 4, do we get 16 as the answer? Yes, we do. If we multiply 16 multiplied by 4, do we get 64 as the answer? That means the term number 5 should be 4 times term number 3. Sorry, term number 5 should be 4 times term number 4, right? The previous term of its previous term. So term 5 should be 4 times. And what was term number 4? That was 64. So 64 multiplied by 4 is term number 5, that is 256. We'll confirm this if we multiply by 4. Just to confirm, multiply by 4, that is 1024. Yes, it's clear. It's proved, right? So we can confirm through multiplication as well. When we see big pattern changes in a big change in the pattern, then we focus more on multiplication. When there is a small addition of numbers, then we go towards addition. When it's a decreasing sequence with small gaps, then we look at subtraction. Okay? Any questions related to this? Okay, thank you. Let's move on to the next question. Let's see what the next question is asking us. It's asking us to type the missing number in the given sequence. Okay, let's do this. Let's copy this. Okay. So the question number 8 says, find the missing number in the given sequence. It's starting from 0, right? So if we cannot have multiplication over here, why? Because anything multiplied by a 0 would be a 0. Agreed? Term number 6 and term number 7. So we have to find the missing term, that is term number 3. We have to find term number 3, right? So let's see what we can do. Can we find a pattern between the first two? Can I say if this is, we cannot have multi plus 2, right? Let's look at term 4 and term 15. What should be the pattern over here? This should be 14 minus 9 is plus 5, right? That would be the 9 plus 5 is 14. What about between 14 and 20? 20 minus 14 is 6. That means 14 plus 6 is 20. Similarly, 27 and 20 would be 20 plus 7. That means we are following a pattern. 2, it should be 3, right? Plus 3. So what is 2 plus 3? Should be 5. And if we need to confirm, then 5 plus 4 should be 9. Yes, the pattern is there. So we can say the term number 3 is 5. The missing number is 5. This is an addition sequence where each addition to the next term is increased by 1. Okay? Thank you. Let's move on further. Let's look at the next question. Okay, in this case, I think it's still decreasing. Yes, it's decreasing. It says type the missing numbers in the sequence. I just copy it on the screen. The question number 9 we have is this. Okay, just a minute. And the question says, question number 9, type in the missing numbers. And these are the missing numbers. The first thing for our own reference, we do type term number 1, term number 2, term number 3. We need to find term number 4, term number 5, and term number 6, right? Let's see what can be done over here. We see the pattern is decreasing because the first term is 78 and the last term is 53. That means it's decreasing, right? So let's see the difference between these two numbers. Wherever 58 minus something would be 53, right? So 53 plus something is 58, the other way around. So when we find the difference, that is -5. Let's see if we have the same difference in these. 78 minus 73 is less, subtracted by 5 less of it. 73 minus 5, it's still, that means the numbers are not changing. So 68 minus 5 should be equal to the next term in the term number 4 in the sequence. So we can say term number 4 is term 3 minus 5, whatever that is term 3. So term 4, that is 68 minus 5. Term 4 comes out to be 63. Let's prove over here. 63 minus 5 should be 58. Yes, it is. So every term has, the next term is being reduced by 5 of its previous term, right? So the pattern over here is that a difference of 5 for each term. Okay, do we understand this, or are there any questions? If there are any questions, please let me know. Okay, good. Can we move on to the next question? Yes, thank you. Let's look at the next question. The next question is kind of a bigger sequence. Okay. Let's say the next question was, okay, sorry. Yes, I have this question with me on the screen. Question number 10. Okay, the numbers, a lot of numbers over here, right? I think there would be 10 numbers in the sequence. Let's count them first for our own convenience. This is term 1, term 2, term 3, term 4, term 5, term 6, term number 7, term number 8, term number 9, and term number 10 we need to find. While we are looking at these numbers, and they have a very huge jump. This is 1, 8, 27, 64, 125. So we cannot see a particular number that is being added or subtracted, right? But once we are looking at these numbers, we should remember that 8 is a cubic number, right? 27 is a cubic number. 64 is a cubic number, right? 125 is a cubic number. 5 multiplied by 5 multiplied by 5 would be. So when we can assess, when we can see the pattern just by looking at the question, right? What the pattern we can see is term 1 was 1 cubed. Term 2 was 2 cubed, right? That would be 8. Term 3 would be 3 cubed is 27. Term 4 is 4 cubed. This is 5 cubed, and so on. Then this number should be 10 cubed. That means 10 multiplied by 10 multiplied by 10. 10 multiplied by 10 is 10 multiplied by 10 is 100. Okay, I'll write it down. Term number 10 comes out to be 10 exponential 3. That means 10 multiplied by 10 multiplied by 10. 10 multiplied by 10 was 100 multiplied by 10. When we multiply numbers ending with a 0, 1 multiplied by 1 was 1, and we simply write the 30. That means this comes out to be 1000. Term number 10 for this given sequence, right? That means every number on its terms position is a cubic number. Okay, agreed? Okay, that's good. So let's try some questions from the test. Okay, I'll give you some time as well. We do some questions from the test, and let's see. Let's click on the test. Let's do it together so that we all have the same answers. The first, there are 10 questions only in the test. We'll try to do the maximum number of questions, and what would be left would be for your homework, okay? So I'll write down the heading for the test so that we know which questions are from the test. This is the test, and we say the question number 1 is this. Okay, this is question number 1. Let's say this is, I'll just change the positions. We have 2 options given to us, option A and option B. This is question number 1 from the test. Okay. So they are saying us type the missing numbers in the sequence. We can see that sequence is starting from a 0, right? 0, 0, 1. That means it cannot be multiplication in any case. Agreed? Because if we have multiplication there, that means it would become a 0 itself. So we can look at, what can we look at? We did this previous question, similar question. What we can say is we need to look at a pattern. Let's suppose this was term number 1, term number 2, term number 3, term 4, term 5, and term 6, term 7, and term 8, right? I'll help you out with the first question so that you do the next question. Or if I'll give you some time, give you a few seconds to think over it. Can anyone give me an answer? Option A or option B? Let's see first, right? The first term is 0. The second term is also 0. That means nothing is being added over here, which we can significantly, something can be added, but multiplication is impossible here. But there must be something that, but from term 2 to term 3, it changes from 0 to 1. That signifies that something is there. So if we say that plus 1 is done over here between term 1, right? Between term 2 and term 3, what can be done between term 3 and term 4? It's, yes, it is. Thank you. Thank you for your answer. It's increasing from 1 and it's going to 3. That means 2 is added to it, right? Can you try to find the pattern? Please try to find the pattern over here. Because in the initial case, there is still a pattern. 0 was added. 0 was added to the term 1 to give first term plus 0 is gives second term. Term 2 plus 1 gives term 3. Term 3 plus 2 gives term 4, and so on. So which term 6 should be 10 or 12? Can I have the answer? See, the first term is 0. 0 plus 0 gives second term. That would be 0, right? So 0 plus 1 gives term number 3. Yes, very good. Thank you so much. Ethan, right? Thank you, Ethan. That means over here, 3 plus 3. And the next one was? Thank you. That is 10 is your answer, right? That's correct. Plus 4 give. But what we need to see over here is, this is an MCQ. 10 is a correct answer, right? 10 is term 6. But in an MCQ, we need to follow the option. So which option should be the correct? 10 is correct. Term 6 is 10. A or B? Because we need to click, right? So you will click on the option number A, which says 10, right? Remember that. We follow the option numbers. Okay, thank you. You're welcome. Let's try the next question in the next number in the sequence. Let's try to simplify and see. I'll just copy the question on the screen. The second question we have is this. Okay. And the question number 2 says the given two options we are, sorry, I'm so sorry. I'll just realign this. Okay. This is question number 2. Type the next number in the sequence, right? The first number, yes, it's a recursive sequence. Thank you. So we need to find the next number in this sequence. Can we look at, because the numbers are increasing, but there is not an abrupt change, right? There is a continuous change in the numbers, right? So can we look at the difference between the numbers? Let's try and see if there is a pattern in the difference. 4 plus something, this is term number 1 and this is term number 2. 4 plus a number would be equals to, yes, thank you. Let's try to find out option A. Yes, it is 60. Let's do it together. Thank you for the answer. This would be plus 2. This is plus 4, right? Plus 6, plus 8. Yes, that is a quadratic sequence. Yes. This is plus 10, plus 12, and plus 14. Thank you, both of you, for your answer. Okay. This would be 60. That comes as a 60 over here, right? I'm not naming the sequence. Okay. No, we don't argue, right? I said thank you to either of you, both of you, right? Both of you. We are discussing. It is a quadratic sequence because the numbers have been increased by, each addition is increased by a per certain number, right? Okay. Let's focus here. Okay. Let's focus on the next question, please. Can I have the answer to the next question? Let's see what answer we have and who can give the correct answer, right? Okay. Question number 3 from the test will be this. Let's do question number 3. Let's focus here. Option A or option B? This sequence is a decreasing. Okay. So this is the decreasing sequence, right? The first term is given to us, the second is missing. So we need to skip the second and we need to go on to the third and the fourth, right? It's option number A. Thank you. Let's look at the sequence over here. 70 minus 8, right? This would be, what is the difference? It's the same. It's subtracting 8, right? This is still a subtraction of 8. That means 86 minus 8. That's a difference of 8, right? That is 78. Yeah. Negative 8. Okay. Thank you for your answer. Okay. We also have a formula for the arithmetic sequence, right? That is, the term number 1 is always considered as A, and to find the term number Tn is equals to A plus n minus 1 times the difference. How do you find the common difference? The common difference is always taken as term 3 minus term 2 and so on, right? Or term 4 minus term 3. That would be, I'll write down term 4 minus term 3 over here. That's because it's given to us. Term 4 minus term 3, that is 62 minus 70. The common difference comes out to be negative 8. When we apply it in the question to find the term number 2, that means n is replaced by 2. The difference is replaced by, and A is always the first term, right? That means 86 plus 1 multiplied by minus 8. That is 86 minus 8. That is 76. Yes, it is a arithmetic sequence. Okay. Okay. Thank you for the answer. Okay, let's try the answer over here. That is 78. Yes, it is 78. Thank you so much. We move on to the next one, and This, I think, is more of a geometric. Let's see. Okay. Question number 4. Let's see whether it's geometric or a random sequence. 0 to 4. Oh, sorry. It's not a 4. 0 2. Let's look at the differences over here. That's a +5, right? +6, +7, right? Then this should be +4, or this should be -4. So 9 minus 4 is? What should be the answer? Option A or option B? Yes, 5 is your answer. That is option number A. Thank you so much for the answer. Okay. Let's try a few more. We are done halfway already. Let's, like, we're on the 5th question now, and there are a total of 10 questions left, right? Total of 10, and we are done halfway. So I would suggest and I would request you people to complete the remaining questions, okay? Once we are done with the class. A few, maybe 1 or 2 would be left. How about this? This is not an arithmetic, right? But this is a geometric sequence over here. So how do we simplify a geometric? In case of geometric, we always find the ratio, right? We find the ratio, and ratio is always the term with its previous term. The ratio comes out to be 2. We need to confirm the ratio. 4 upon 2, it's still 2, right? That means the common ratio is 2. And the formula that we can use, we do not need to use a formula over here, but we can always use a formula. Yes, it is 8. Thank you. But let's suppose if they would have asked term number 35, that would be difficult for us, right? So in a geometric sequence, the formula for the sequence is Tn is equals to a multiplied by r to the exponential n minus 1, right? This is simple. Term number 4, we know it comes out to be 8, right? But if they would have asked a bigger term, then what we need to do is we need to remember this formula and apply the values. A is always the term 1. Term 1 will always be considered as A. Ratio would be always common ratio. It has to be a common ratio. Okay. Let's try one more question. Thank you for the answer. 8. I just clicked on it. Okay. Let's try this. What is the missing number in the pattern? We did a similar question already. Let's see what is the answer for this. Question number 6. Can we have the answer to this sequence? Option A or option B? What we can see over here is if this is term number 1, term number 2, 3, and so on. What we can see is that the value of the term is basically deduced from the term number position, right? So we can say if this is 8, we can say 2 cubed, 3 cubed, 1 cubed. 64 should be 4 cubed, 5 cubed. I need to write a cube. This should be 5 cubed, 6 cubed, 7 cubed, 8 cubed, 9 cubed, and this is term number 10. That means it should be term number 10 should be 10 cubed. And we know that term number 10, when 10 is cubed, its answer comes out to be 10 multiplied by 10 is 100, and 100 multiplied by 10 would be 1000. Okay, so we click on the option B and we say 1000 is the answer. Okay. Four questions are left for this topic. Kindly complete those four questions and go through the test. Okay, thank you so much. Thank you for answering. Have a nice day. Take care. Bye.